Hi, my name is Shane Sylvester. My final project for this Solids of Mechanics course is a close structural analysis of a loaded arch. This project will focus on creating a fully validated finite element model of a loaded arch with defined geometry, boundary conditions, and loading. This arch model will be validated using various techniques and applied to the well-known real-world structures of aqueducts. This project update will focus on four main points: initial research, a review of previously constructed finite element models in this course, an establishment of what validation approaches will be considered, and an identification of what potential additional work scope might be undertaken for this project. Initial research for this project consisted firstly of looking for real-world connection to the topic of arches. I looked for inspiration in a number of fields, but was eventually drawn to the use of arches in ancient Roman structures, most famously the Roman aqueducts. I explored the topic of arches, including geometries and construction of arches, through basic sources such as Wikipedia. I then looked deeper at the topic of structural analysis of arches. I took a scholarly approach, considering a wide range of academic articles on the topic. The four links that are shown here were the strongest, most applicable pieces of scholarly literature on the subject available. Each considers a different aspect of arch analysis, including some of the topics that I will discuss later as potential work scope additions. My next step was to look at previous coursework, both in this course and others in my degree program, to determine if there were any applicable models that could be used as a baseline or starting point in my analysis. I was able to find one that I had created earlier in this course on Homework 5, analyzing a tunnel through a granite underground. It compared the use of a semicircular arch tunnel to that of a simple box. The model, while very different in loading and geometry than my intended project, provides a strong starting point for how to address my finite element model. It provides a clear picture of where I might see high-stress regions, and it establishes an example baseline for boundary conditions in a two-dimensional finite element model in COMSOL. This project will have a central standard case that it will focus on, be known as the standard case or the base case. As mentioned before, this will be intended to mirror one segment of an aqueduct. It will be comprised of a semicircular arch with a 10-meter inner radius. The material will be concrete, with properties taken from engineering toolbox and other sources as needed. Boundary conditions will be fixed ends and a pressure load across the arch based on a piecewise function designed to mirror water flowing over the archway. This will be accomplished with a peaked loading in the center of the arch defined by what would be essentially a step function with certain water load and side loads for the side structure. Additional focus areas are listed below as potential expansion topics. If, and only if, there is ample time to address these ideas, some of these concepts may be added to a then fully validated model to learn more about the real-life application of some of these concepts. These include applying thermals of a summer or winter environment, weather conditions such as stormy weather or acid erosion of the aqueducts, applying multi-material reinforcement to the arches, such as fiberglass, steel, or additional concrete, adding conjoined arches, modifying the geometry of the arch by making it a wider arch, a parabolic arch, or a half arch or canopy, or making the arch a composite arch made of multiple brick-like components, such as what you would see in a masonry arch. Before any of these additional work scope items would be considered, the project will focus on validating the standard model with the limited time available. There are also a number of approaches to validation, and each will be worked in the listed order in order to ensure that there is adequate time for each item. This validation includes mesh extension studies for validation of the finite element model, looking at element shape, element size, and element order. A literature review in comparison of empirically or otherwise analytically derived values to this model. A hand-calculated analytical solution with a determinate or indeterminate solution using Maple. And potentially an analysis with two different programs, ANSYS and COMSOL, in order to remove the variability existing within any given finite element software program. These will be worked in order and addressed where possible. The next steps for this project are working on the base case model, building it up as described in this project update. The work will use the geometry, loading, and boundary conditions described herein, and will then proceed to initial validation of the model. The validation will work in the order described previously, starting with mesh extension studies and an analytical solution for the arch analysis. I will provide another project update in about a week, and in the end, this will all be combined and summarized in the project report. Thank you for listening to this first project update.